Okay. So, guys, what I really wanted to do with this little stream here is I wanted to go over some more dosage calculation types of questions. I've gotten a lot of questions. I've made dosage calculation video in the past, but I still get more questions about it. And what I wanted to do is I've compiled about 15 questions that I want to go over here with you guys live. And this again will be available after the stream is over. It'll process and it'll upload and it'll be there for you to view from here on out. But I want to go over 15 questions that deal with all different kinds of math types of questions. Simple conversions to IV drips to reconstitution questions, all that, the whole gamut. So, yeah, without any further ado, we're going to go ahead and get into it. Again, I got about 15 questions. If at any point you get a reading on your video that I'm offline, it's a normal thing. It periodically may cut out for just a few seconds, but I'm live, okay? So we got about 15 questions I'm going to go through here. And yeah, I hope this helps you guys out. And hopefully you start knocking out those dosage calculation questions. I'll say one other thing that my dogs are here beside of me, so if they start barking, forgive me, but they'll stop soon. But anyways, all right, so we're going to go ahead and get into this. So, and I'm going to write these out, so again, please do bear with me here. So this is the first one. And forgive my handwriting, I hope you can read it, okay? We're going to start off a little easy. Now, by the time I'm finished writing this, you may already have the answer. But the physician has ordered Lasix. Let me make sure that we can see this here. All right, good deal. So, the physician's ordered Lasix, 120 milligrams PO. The pharmacy sent Lasix 40 milligram tabs. How many tabs should the patient receive? Now, whenever we look at dosage calculation questions, and this is true of any question, you need to read the entire question, right? We hear that all of the time. You need to read the question all the time, or you need to read it thoroughly. The reason is some key things that you need to look for whenever you're reading questions. Units, okay? Are these units the same? For this question, they are, because that is like one of the number one reasons that nursing students get simple questions wrong, is because if this happened to say micrograms instead of milligrams, and you didn't read, they look so similar, and you didn't read every little stitch of the question, then you may get it wrong. So definitely look at your units, and then ask yourself, what is the question really asking me? Now, different nursing programs teach dosage calculation conversions in many different ways, okay? I'm going to give you my easy way of doing things. This is how my brain works, okay? A lot of people teach the, I can't even remember what it's called, the scientific way of converting things. Here's how you do it, okay? And again, this is an easy question, but you'll see what I mean as we continue to move forward, okay? So the physician's ordered 120 milligrams. That's how many milligrams the patient should receive, okay? But what the pharmacy sent up, what your supply is 40 milligram tablets. So here's the easy way you can do this, okay? It'd be like this. One tablet contains 40 milligrams. One tablet contains 40 milligrams. The physician has ordered 120 milligrams. Since your milligrams are on the bottom here, put your milligrams on the bottom over here. 120 milligrams. We need to know how many tablets the patient's supposed to get. So X, that signifies our unknown. Okay, and again, tablets are over here, so tablets will be over here. And here, all you do is you simply cross multiply, right? I'm sure you guys are like 20 steps ahead of me already, but For those of you out there who, this is for everybody, okay? Some people are still at the beginning level. Cross multiply. 40 times x is 40x. And I hope you can see the bottom of this board. Let me look. Yeah, you can. Okay, good deal. And then 120 times 1 is simply 120. And then you divide by 40 on both sides. X equals trace 3. 3 tabs. Okay, I'm not going to write all that out. 3 tablets. So that is your basic question. All right, what is your question asking? Are the units matching up? And then it's a simple matter of cross multiplying. Okay, your answer for this one is 3 tablets. I hope that made sense. And again, bear with me. I want to throw out questions for all different levels of students. So if you're more advanced, good for you. That's awesome. But we'll move on to the next one, okay? This is number 2. I cannot write. And I'm also kind of sitting sideways, so this is awkward for me to write like this anyway. And this is going to be a long video, so, don't feel like you got to stay for the whole thing, but if you don't feel like you have a good grasp of things, then you may definitely want to stay. Somebody let me know down below if that helped or not. Let me click play. Yeah, so that helped. Trying to work out all these kinks. All right, that's better. Very good. Okay, so moving on. I apologize. So, X equals 5 milliliters. But let's remember, the physician ordered this every 6 hours. So this is 5 milliliters every 6 hours. Okay? But we want to know how many meals the patient needs to get in 24 hours. Okay? So to get to 24 hours, you times 6 by 4, right? 6 hours times 4 equals 24 hours. We need to times the top by 4 as well. So 5 milliliters times 4 equals 20 milliliters every 24 hours. All right, I'm just making sure that this audio is good. Okay, so there's your answer. 20 mils every 24 hours. I hope that made sense. I know that I had to stop midway through that problem. But again, we're looking at our units. Do they match up? We're looking at our time that is ordered, and we're looking at what the question is actually asking. They wanted to know 24 hours. So we needed to make sure that we recognized that 5 mils was only for the every 6 hours. The question wanted to know every 24 hours. Now, if the question had asked how many milliliters should the patient get per dose, well, the physician ordered every 6 hours, and this is 5 mils every 6 hours. So the answer would have been 5 mils if it had asked per dose. Let's move on to the next question. Now that we have these audio issues squared away. All right. This is number 3. I'm going to try and break these questions down a little more simply without all of that chicken scratch. Oh, yeah. Okay, so this is question number 3. The physician orders Robitussin, 30 milligrams every 6 hours PO by mouth. The pharmacy supplied us with Robitussin, 5 milligrams in 2 milliliters. The question is asking how many milliliters should the patient receive per dose? Okay. Again, do our units match up? They do. So let's approach this just like we did the previous one. The information that we know is that our supply contains Robitussin, 5 milligrams in 2 milliliters. Oh my God, guys, you wouldn't believe this chicken scratch. In 2 milliliters. The order is 30 milligrams every 6 hours. How many milliliters per dose? So milligrams are up on top over here. We put milligrams on top over here. How many milliliters per dose? The milliliters are our unknown. So we put an X down there. Again, you cross multiply. 5 times X is 5X. 30 times 2 is 60. You divide by 5 on both sides. X equals, I should know this right off the top of my head, 5, 10, what is it, 12? 12 milliliters. This is per dose, right? So I hope that that made sense right there, okay? The order is 30 milligrams every 6 hours. We're given 5 milligrams in 2 milliliters. So whenever you're looking at these math questions, really, the reason why a lot of people like math is because math is simple. There's not a lot of rationale behind it. It's simply knowing how to plug numbers in to a formula, if you will, and coming up with an answer. So we knew that 5 milligrams was in 2 mils. We knew that our order was 30 milligrams. The unknown was our milliliters. Since milliliters are on the bottom here, milliliters are going to be on the bottom over here. You simply cross multiply. 5 times X is 5X. 30 times 2 is 60. You divide by 5 on both sides. And what you're left with is X. Remember again, X was your milliliters. X equals 12 milliliters. And that is 12 milliliters per dose. Okay? Very good. I hope that that one made sense as well. Here's your next one. This is a reconstitution one. Okay, so we have an order for prednisone, 250 milligrams via IV. The pharmacy supplies it. They supply 500 milligrams of prednisone. The label reads to reconstitute it with 10 milliliters of normal saline. After reconstitution, after we have inserted 10 milliliters of normal saline into what the pharmacy has supplied, it yields 125 milligrams per 2 milliliters. How many milliliters should the patient receive? So, again, how do we approach this? Do our units match up? They do. Okay? Milliliters, milliliters. It's all good. If we have a yielded reconstitution of 125 milligrams per 2 milliliters, and what we're supposed to give is 250 milligrams, how many mils should they receive? This is indeed still a simple conversion question, right? Milligrams is on top. The unknown milliliters is on the bottom. Cross multiply. 125 x, 125 times x, 500, x equals 4 milliliters. And there is your answer. So the reconstitution questions, you can get them in different shapes and forms, but this one, and these are the way in which I've seen them most times, is relatively straightforward. It gives you all of this nonsensical information, okay? But all you got to do is you got to sit there and you got to look at the question and what it's asking. And so basically you look at it, right? Look at your numbers. It's the order, 250 milligrams. What does the pharmacy give you? 500 milligrams. It's reconstituted with 10 milliliters, yada, yada, yada. But what does it yield? It yields 125 milligrams per 2 mils. 125 milligrams in 2 milliliters. Our order is for 250 milligrams in how many milliliters? You simply cross multiply and you get yield of 4 milliliters. I hope that one made sense. I've gotten questions from people about reconstitution questions before, and there can be some that are quite difficult. But most times, again, from what I have seen, they are most times just like that. Relatively straightforward. It's a matter of simple cross-multiplying conversion. So here's number 6. And this is a long one. And you very well can and will see a question just like this. Okay. The physician orders heparin for a patient. Protocol says to bolus the patient with 50 units per kilogram IV and to initiate an IV drip at 8 units per kilogram per hour. The patient weighs 220 pounds. The pharmacy sends up a heparin vial at 5,000 units per milliliter. The heparin IV bag is supplied as 25,000 units in 500 milliliters. Calculate the bolus and the pump setting. Now, that's a lot of information. And on top of that, this question is asking you for 2 separate answers. So whenever you're approached with this kind of question, this might be overwhelming as crap. But don't let it be. Focus on one thing at a time and knock it out. So let's work our way through this, okay? What is our nitty-gritty need-to-know information? We bolus the patient 50 units per kilogram, okay? So let's simply start there. We need 50 units per kilogram. That's per kilogram of patient's body weight. How much does the patient weigh? They weigh 220 pounds. So we know right now we need to convert their weight in pounds into kilograms. Okay? So how do we do this? Again, you will get a lot of questions that require you to convert from pounds to kilograms and vice versa. So this is something that you just have to know. Okay? One pound is equal to 2.2 kilograms. So if we need to convert their weight in pounds into kilograms, you divide by 2.2 to get their weight in kilograms. This patient weighs 100 kilograms. Okay, now that we've got that established, protocol says to bolus the patient with 50 units per kilogram. So that means for every 1 kilogram this patient weighs, they need to get 50 units. Well, this patient weighs 100 kilograms. So you do 100 kilograms times 50 units. Because they're getting 50 units for every kilogram that they weigh. I hope that made sense. Okay? So as far as the bolus is concerned, they need to get 5,000 units. Okay? Pharmacy sends up a heparin vial at 5,000 units per milliliter. So if it's 5,000 units per milliliter is what we're supplied with, and the patient needs 5,000 units, then what they're going to get is the 1 milliliter. That's the answer to the bolus question. Okay, I hope that made sense. We converted their pounds into kilograms because they are ordered 50 units per kilogram. So then we did the 50 units times their weight in kilograms to give us the total amount of units. And we know that the pharmacy supplies us with 5,000 units per mil. Since they need to get 5,000 units, they're going to get the whole milliliter. That's the bolus. So now that you've knocked out the first part of the question, you now move on to the second. That's how you approach these. So let's move on to the second. We want to know the pump setting. So they say to initiate an IV drip at 8 units per kilogram per hour. Okay? We know that the patient weighs 100 kilograms. Okay? And this IV drip is supposed to be at 8 units per kilogram. So we do the 8 units. Okay, hope you're with me. For a total of 800 units per hour. Okay. Now, what we know is the heparin IV bag is supplied at 25,000 units in 500 milliliters. Okay? We know that what this patient needs is 800 units. What we don't know is how many milliliters that they need per hour. So we have to do, again, the what's the word? The simple cross multiplication that we've done previously. Because what we know we have is 25,000 units in 500 milliliters. What we know the patient needs is 800 units. What we don't know is how many milliliters they need. So at this point, again, cross multiplication. 25,000 times X equals 25,000X. 800 times 500 gives you 400,000. You divide by 25,000 on both sides. Leaving you with, and I do have to use a calculator, leaving you with 16 milliliters per hour. I don't know if you can see that part of the board or not. Hopefully you can. And so again, for this second part of the question, we figured out how many units per hour that they needed. But what we needed to know is how many milliliters per hour. So again, we take what we know, what we're supplied with, 25,000 in 500. You do the simple cross multiplication, giving you your answer of 16 milliliters per hour. So all of that information, it required many different mathematical steps, but we ended up getting the answer. And I hope that that question made sense. Again, feel free after this video is over to rewatch it. And if you're watching this now for the first time, then feel free to hit rewind. But that's how you break it down. You're looking at all of your units. Does everything match up so that you don't get confused? Take it one step at a time. Don't try and solve both answers at the same time. Solve one at a time. Hey, little doggies. Calm down. People are trying to learn here. You got enough distractions going on as it is. All right. We'll move on to the next one. That was a long question. This is number 7, okay? Let me know down in the comments if this audio is still coming through good, since I did have to cut it off and cut it back on. if you wouldn't mind. Okay, very good. So, calculate the drip rate for 200 milliliters of IV fluid to be given over half an hour via an IV set that delivers 15 drops per milliliter. You will see a lot of questions like these. The GTT, that's drops. So, I don't want to go into deep detail about why we have drops per milliliter. It had to do with the old school nursing before pumps came about, and they actually had to count drops and everything. So calculate the drip rate for 200 milliliters of fluid to be given through an IV set that has 15 drops per milliliter. So think about it. If we have 15 drops per 1 milliliter, and what we have is a total of 200 milliliters, you need to do 15 drops times 200 milliliters. 15 drops per mil. Which gives you 3,000 total drops. Okay? That 200 milliliters of fluid literally contains 3,000 total drops. We know that it needs to be given over half an hour. Now, another thing that you need to know is if you're calculating drip rates, these answers are always in drops per minute. Okay? So, we have our total drops, and we know it needs to be given in half an hour. How many minutes is in half an hour? 30 minutes, right? So what you do is you do your 3,000 total drops divided by your 30 minutes to give you your answer in drops per minute. And that's your answer. I hope the way that I broke that down made sense. You have an IV set, 15 drops per 1 mil. We have a total of 200 mils, so you do 15 drops times your total of 200 mils to give you a total of 3,000 drops. We need to know what the drip rate is. Drip rates are calculated in drops per minute. So you do your 3,000 total drops divided by 30 minutes to give you an answer of 100 drops per minute. That is your drip rate. I hope that made sense. And I'm sorry that I keep saying I hope that made sense. I know that dosage calculation can be tricky, and there's a lot of different questions that they can ask you, and there's a lot of different ways in which they can ask you that question. So again, what I wanted to do with this is work through some with you. Hopefully if you're still new to dosage calculations, you'll begin to make those mental connections and form a little foundation of knowledge about how to approach questions. And from there, take a crap load of practice questions on your own and really begin to knock them out. And then once you do that, you'll have the hang of it so much so that whenever you have to take those dosage calc questions every single semester, you'll feel a lot more confident doing so. Okay. 1/2 liters of normal saline is required to be given over 4 hours. Using a set that delivers 10 drops per milliliter, how many drops per minute need to be given? This is the same kind of question as our previous question. It's just asked in a different way, and it makes you do a few conversions in order to get to your answer. So again, whenever we look at our question, where's our nitty-gritty, need-to-know information? Our total amount of fluid is 1/2 liter. Now, in your mind, if you already know the answer to how many milliliters is in a liter, let's just do that, because you have to have your answer in milliliters, okay? It can't be in liters. 1 liter is equal to 1,000 milliliters. What we have is 1/2 liter. So what we actually have is 500 milliliters. I hope that made sense. 1/2 liter of normal saline. Or in other words, 500 milliliters of normal saline. 500 milliliters of normal saline is required to be given over 4 hours. Using a set that delivers 10 drops per milliliter, how many drops per minute need to be given? So, the set delivers 10 drops per 1 milliliter. We have 500 milliliters, so we times that by 10 drops to give us 5,000 total drops. All right? How many drops per minute? Again, drip rates, they're in drops per minute. However, our time frame is not given to us in minutes, it's given to us in hours. So we need to convert 4 hours into minutes. You could probably do this in your head, but if you can't, 4 hours times how many minutes are in an hour? 60 minutes, to give you a total of 240 minutes. We need to give 5,000 total drops over 240 minutes. So you simply do that calculation. And what it comes out to is 20.8 drops per minute. However, we're talking about drops of fluid, literally. There's no way that you could give 20.8 drops, right? You can't give 0.8 of a drop. It has to be 1 drop. And so these numbers have to be rounded. So if you have 20.8, what you really have is 21. You round up or you round down accordingly. 20 drops per minute. Or sorry, 21 drops per minute. Half a liter of normal saline has to be converted into milliliters. So we have 500 milliliters of normal saline given over 4 hours at 10 drops per mil. So 10 drops per 1 mil. You times it by the 500 milliliters to give you 5,000 total drops. It's got to be given over 4 hours, but our answer needs to be in minutes. So we converted our hours into minutes, and we did our 5,000 total drops divided by our 240 minutes to give us how many drops per minute, like the question asked. How many drops per minute? In other words, your drip rate. I hope you got it. These questions really are, it's just repetition. Since I've had technical difficulties and since this video is dragging on to be quite long indeed, what I'm probably going to do here is probably just give you 2 more questions for a total of 10 questions, okay? And so what I want to do is I'm going to give you, for these last two questions, you'll see this on an exam. I have, you will as well. It's two questions basically where the order gets changed after the first question. That's hard to describe, just for the purposes, bear with me, okay? You'll see what I mean, okay? All right. You have an order for a patient with diabetes to receive regular insulin IV at 14 units per hour. The concentration of insulin is 100 units in 250 milliliters of normal saline. How many milliliters per hour should the IV pump be programmed for? So, our order is 14 units per hour. Our concentration is 100 units in 250 milliliters. Question is asking mils per hour. Nitty gritty, need to know information, right? So we have 100 units. This is our known information. And 250 milliliters. What they need is 14 units. Okay? You do the simple cross multiplication. 100 times x is 100x. 250 times 14, 3,500. Divide by 100 on both sides, leaving you with 35 milliliters. Okay? The concentration of insulin sent was 100 units in 250 milliliters. The order was for 14 units per hour. How many mils per hour? And this would be 35 mils per hour. Okay? Now, what I was talking about before I began this question, how on an exam you will get two questions in a row that basically pertain to the same situation. Here's your second question, okay? Here's your question number 10, basically. If the insulin in this order right here is reduced by 4 units per hour, how many mils per hour should the IV pump be programmed for? Okay? The insulin up here is reduced by 4 units per hour. Now, how many milliliters per hour will this patient be getting? So if our original order was 14 units per hour, and we're now reducing it by 4 units per hour, we're doing 14 minus 4 to give us a total of 10 units per hour. That's what the patient is supposed to get. This information of what we're supplied, 100 units in 250 milliliters, that's still staying the same. So again, 100 units in 250 mils. And what we have is 10 units per hour. And your unknown is your mils. Again, you're doing the same cross multiplication, right? 100 units times X is 100X. 250 times 10, 2,500. Divide by 100 on both sides to give you 25 mils per hour. I hope that wasn't confusing. That is how you will receive some questions on an exam. They'll give you an entire first scenario, and you're going to work through that problem. And you're going to come up with your answer of 35 mils per hour. That's what the question asked. Then your second follow-up question is going to still pertain to that same information. We're reducing that original order of 14 units per hour by 4 total units. So now the patient, instead of receiving 14 units per hour, they're going to actually be receiving 10 units per hour. Based on that, how many milliliters per hour should the patient now be getting? And our supply stayed the same, and that can confuse some students. Our supply never changed. So we still have that same 100 units in 250 milliliters. Now all that's changed is how much the patient's getting. 10 units. And then you still do that same cross multiplication. 100 units times X is 100X. 250 times 10 is 2,500. Divide by 100 on both sides. You get 25 mils per hour. That is dosage calculation, guys. And I'm sorry for all of the mess ups that have happened in this video. It aggravates me as much as it does you. I hope that it didn't deter away from the overall message of how to solve dosage calculation problems. You take a look at what you're given. You have a lot of filler information that is unnecessary. All this wording, don't worry about it. What is your nitty-gritty need-to-know information? Once you can pluck that out of the question, do your units match up? Is it milligrams to milligrams, or is it milligrams to micrograms, right? Do your units match up? After you have your nitty-gritty need-to-know information, right? And your units are the same, and if they're not the same, do your conversions. Once you have that and your units are the same, what's the question asking? And from there you can solve the problem. And again, there's some things that you just have to know, right? If it's an IV drip rate, it's got to be in drops per minute. If you're talking about pumps, it's got to be in milliliters per hour. If you got to convert pounds to kilograms, you got to divide the pounds by 2.2, vice versa. That's how you answer dosage calculation questions. I know that there's so much confusion when it comes to these questions and the way that they're taught by instructors at different campuses. I saw one of you commented at the very beginning that I explained this so much better than your instructor. I'm sorry that it's so complicated sometimes. But once you understand how to approach questions, you understand those simple formulas, those cross multiplication, and how to basically plug the information that you're given into an algorithm in your brain, the formula, and answer the question. Once you figure out how to do that, and then you do hundreds of them, whenever you're presented with that dosage calculation test, you're going to see the question. You're going to know immediately what it's asking, what information is important, how to plug that information into the formula that you already know, and from there, answer the question successfully and pass those dosage calculation questions. That's all I got for you guys. I hope you enjoyed the stream. I apologize again for all the problems, but I hope that you got the overall message. If For those of you who are going to be watching this now, after the fact, I hope you enjoyed the video. Be sure to hit the subscribe button, leave a comment down below, and I'll catch you guys in the next video. It's your boy Nurse Bass, soon to be. Peace out, guys.